Hi, I just feel compelled to do another video on exponential and logarithmic material. Um, with any equation, like if you had 2x plus 5 equal 13, you can guess and check on that. You can look at that equation and you can think to yourself, okay, what would this need to be so that this would all work out, and see that it's 4. Okay, but there's a algebraic process you can use for solving, okay, where you subtract 5 and divide by 2, okay? And it's this process that's really one of the big points of algebra, is to show you these processes for solving equations, okay? So when you get into the exponential stuff, I'm starting to see that you may need more help with how to show the process. I don't want the guess and check idea being used. The whole point of what we're doing is learning that process right there. So that's what this video is about, is just helping you to know how to show your work, okay? So I'm going to do a couple log equations similar to what you'll see on the test. So what if you had like log base 4 of x minus 5 equals 3, something like that. All right, and you were asked to solve that, okay? Here's what I expect to see. Here's the kind of work that I expect to see. I expect to see you either be thinking, okay, this is log base 4. So to undo that, I need to do 4 to the left side, 4 raised to the log base 4 of x minus 5. And I need to do 4 to the right side, okay? Or some of you learn to do that by just changing from one form to the other. Or you start with your equation and you think to yourself that this is the base, this is the exponent on the base that I would need to get x minus 5, okay? Either one of those is going to lead you to 4 to the third equaling x minus 5. Okay, so the 4 that's exponential, the function that's a base 4 exponential, and then a log function base 4, they undo each other. This is really composition of functions. So we've just undone the log base 4, and so all we have is x minus 5 on the left side, and then 4 to the third is 4 times 4 times 4, so that's 64. Okay, all right, so and then you could continue if you did that. And then everybody should see at that point that you would add 5. And so your final answer would be 69. So I want to see work. I want to see this step or this step, okay? That's important. All right, so there's one example. All right, let's do another log example. So you might have a problem where you have a log in more than one spot. So like here's one. Okay, so this one has subtraction. Okay, so that means that when I condense my logarithms, because we have log in more than one spot, we're going to put it together. Then we're going to condense the logarithm, and it would be changed to division inside here, kind of like the exponent properties did, and we'd be to here. All right, now I don't want to see things that you really don't understand, that you're just getting from somewhere, or that is not a process that we've kind of talked through. Let me show you what I mean. So down here, okay, all of a sudden, sometimes people will do things like log base 5 of 25. Well, I don't think that's something that you came up with or that you understand fully, okay? So that kind of thing comes from those apps. So that I shouldn't see that. Just use the process we've been working through. We're going to condense into one logarithm, and then at this point, we're going to undo log base 5 by doing 5 to the left side and 5 to the right side, or by changing that problem at this point into exponential form. You can think of it either way. This is the way I've been showing it. All right, and then the exponential base 5 and the log base 5, they're perfect inverses. So we get x plus 2 over x minus 3 equals 25. And now you have to continue showing me your steps, okay? So you're going to come in and you're going to multiply both sides by x minus 3. That's going to leave you an x plus 2 equaling 25x minus 75, because that's just multiplication. That's not an exponent. All right, then I need to get my x's together. Okay, and that's going to give me negative 24x plus 2 equals negative 75. So now I'm going to subtract 2. I get negative 24x equals negative 77. And then I'm going to divide by negative 24 on both sides. All right, and you do want to write that fully simplified. So you go ahead and do that. And you get a positive number. And it turns out to be positive 77 over 24. All right, now that feels weird. So a lot of times I'll go back up just to double check my work and make sure I didn't mess anything up. Because I'm used to things turning out nice just like you are. So I'm checking right here. I made it division. Okay, I did 5 to both sides. I got a 25 here. Those would cancel out, and looking good so far. Multiplied both sides by x minus 3, leaving me x plus 2. That would be 25x minus 75. Okay, so I don't see anything incorrect. Subtract the 2, get a negative 77. All right, it's got to be that. Now, the reason I didn't just plug that in is because my calculator doesn't do log base 5. Okay, but I could on some calculators. But anyway, I can't check it easily, so I just went back through the process. And then once I'm pretty sure, I'm going to put that down as my answer. Okay? All right, now let's look at a couple exponential ones. So these start out without logarithms. They start out exponential. And then what we're doing is going to go ahead and solve that. So we have 2 raised to the x minus 1 equals 3,157. Okay. All right. So the exponential part is already by itself. So we're going to come in and log both sides. Okay. Now, when you write this, get everything written where it's supposed to be, so your brain is thinking correctly about this. Log is a function. We're doing log of each side. These should be on the same line. And then the x minus 1 should be up a little higher. It's an exponent. Now, log is understood to be base 10, so it doesn't undo the 2, but that x minus 1 can be brought down in front with parentheses around it. So now we have this, and that's just times. All right, equals log of 3,157. All right, so now at this point, this looks hard, but really that's multiplication right there. So, and log of 2 is just a number, and log of 3,157 is just a number. All right, so at this point, there's really 2 routes you might take. Since there's nothing except for a 1 right here, on this one, you might just come in and divide by the log base 2. And look, some of you are crossing out the log separately from the 2. This is a number that you can divide by that number. It doesn't make sense to just cancel out log. You can't just do that. So don't cancel those out individually. It's not the right thinking. So we get x minus 1. So far, we have log of 3157 over the log of 2. And then to finish it, I'm going to need to add 1 to both sides. Okay? And then that'll give me my answer. So this would be my exact answer. Now, sometimes we have issues with typing it into the calculator, so I tried to help you all with that and encourage you to really practice that part of it. You would have to type in log 3157, close the parenthesis, divided by log of 2, close the parenthesis, and then plus 1. And when you do that, you get about 12.624 if you round to the nearest thousandth, and just round. Be careful about rounding to whatever they're asking you to round to. All right, now on this one, there's a different route you might go when you're simplifying. So like at this step right here, some people might have distributed the log of 2. So I want to show that so that you know you're not incorrect. So if you did that, you'd have x log of 2 minus log of 2 equals log of 3157. Okay. And then the x is what you're trying to get by itself. So you would add log of 2 to both sides, but you don't put the 2 with the 3157. That would just be x log of 2 equaling log of that 3157, close the parenthesis, plus log of 2. And then finally, you could divide both sides by the log of 2. And then that would go away, and you'd have x equals, and you'd have log 3157 plus log 2, all divided by log 2. And these are equivalent right here, both considered an okay way to have your exact answer, and both would be this when you finish, okay? So I need to see that. I don't want guessing and checking in here until you figure out that it's 12.6, okay? All right, so keep working on that. That's why I'm going to do this. I think I'll also post the notes. I was really wanting you all to create your own notes because I think that really helps, but I think I'll post the notes from the videos, or at least from that handout. All right, let's do one that has an e in it. So say you had e to the 3x minus 7 minus 2 equals 17,147. Before I log both sides, I'm going to add 2, because the whole process of solving is undoing what's been done to your variable. Okay? Now, at this point, I want to log both sides, but I can save myself some work because this is base e, and that's the base for the natural log. So if I natural log both sides, I can save myself some steps. You know, if you do it thoughtfully and you notice that you have a base of e or a base of 10, then use the appropriate logarithm, because ln is really log base e, and if you raise it, or you do log base e of e raised to the 3x minus 7, since the bases are the same, these undo each other, and all you have right here is 3x minus 7. Okay, so we get to there. All right, now we just need to continue working to undo what's been done to x. So we're going to get 3x equals ln 17,149 plus 7. And then we're going to divide by the 3. And so when we do that, we get ln 17,149 plus 7, all divided by 3. That would be your exact answer. And then you'd need to type it in. Okay, so you're going to do ln, put that in there. Okay, add the 7. And then at that point, you could hit enter, but don't round off, and then divide by 3. And you get about 5.583. Normally they're rounding to the thousandths, but you need to watch that depending upon the problem, okay? All right, so that's what you would do there, and just be careful because this is a grouping symbol, so that whole entire numerator needs to be typed in either in parentheses, or you need to hit enter before you divide by the 3. Okay, so I wanted to do those 4 so you could see what I'm talking about when I say show work. This is what I'm expecting, not just an answer and not just guessing and checking to get the answer. Okay. All right, now let's look at one that was on the compound interest project. So what if you had something that was compounded continuously? Let's do that problem. I did a video on the others, and I thought you'd be able to do this one, but I just want to look at it again. So what if you were investing $5,000. Now let's do $7,500 in an account paying 4% interest, compounded continuously, So that's what you're doing. And you want to know how long would it take? How long to double your money? It's kind of like the third question on the project, okay? So let's try that one. All right, so first off, if it says continuously, then you're going to need to use the A equals PRT. A equals PE raised to the RT power. All right, the 7,500 is what you're investing, so that's your principal. E is a number that's being used as the base. You don't plug anything in for that. The R was 4%, so you change it to a decimal, 0.04. And you don't know your T, you're looking for that, but you want to know when that reaches double. So you invested 7,500, so double that would be 15,000, okay? So you might have more success if you have your variable that you're trying to solve for on the left. So I'm just going to flip the two sides of the equation around to start with. Now, before you log both sides, divide by the 7,500. And you get E raised to the 0.04t equals just 2. Okay. Now, I need to undo E. So just like before, if I notice that and I use ln, it'll save me a step. So I'm going to natural log both sides. This is really composition of functions over here on the left. The log base E and this base E undo each other, and we have 0.04t equaling ln of 2. So we'll divide by the 0.04, and that'll give us t is about, and let me type it in. So I used ln because I had, because it was E, and I have ln on my calculator. So I'm able to type it in. And when I do, I get about 17, and I think it wanted you to round to the nearest 10. So this would be about 17.3. And in this context, it was years, so 17.3 years. Okay. All right, and then one more problem I thought I'd go over on this. Is maybe a change of base formula. Okay, so like if I had log base 15 of, 42.15 equals something, and I'm supposed to figure out what that is, the change of base formula says, yeah, you don't have necessarily log base 15 on your calculator. What you can do is the log of the 42.15 and divide that by the log of 15. You could then, and it would work, by the way, to do ln of 42.15 over ln of 15. Now the logs don't cancel out. This is log of a number, log of a number. These are outputs. These are numbers. So don't think you can just cross out the log. You can't. So you do log of 42.5 divided by the log of 15, and you wind up with that turning out to be about 1.382 if I round to the thousandths place. So you might see a problem like that. I think there was one on the test. Okay. All right, and then I'm going to do one condensing problem. So you might have a problem where you wind up having logs in multiple places. So you might have I'll do a really hard, I'll go ahead and do a really hard one. You might have one like 2 log base 3 of x minus log base 3 of y plus log base 3 of z, something like that. And it might say to condense or to rewrite with a single logarithm. Okay, so if it asks me to do that, this is where you want to look at those log properties. So the 2 is going to have to be brought back on top using property 3. It makes more sense once you see it. Property 3 says the exponent can be brought down in front, but that means it could also have been brought back up on top. Okay, so that's the first thing I'm going to do is use property 3. And then at this point, I'm going to think about how I can condense. If it's subtraction, it goes to division. And if it's addition, it changes to multiplication. And I'm going to go ahead and take care of both of these. So the x squared is on top, but this minus means the y is going to be down here. It's going to be divided by, but then this is a plus, so the z is going to be on top, and it'll be multiplied. And so there you have it. Okay, so that's a condensing problem. All right, we have to condense to solve some of our log equations. Okay, you might also have one that says to expand. Okay, and so like you might start with something that looks like that. Okay, so you might start with something like ln, and then you might have, x, y to the third z over 2, maybe something like that. All right, so when you're looking at that, what you can first do is say, well, I know I'm going to do ln, and I'm going to change the division. Okay, the log of a quotient I can change into the difference of 2 logs. Then all of this is multiplication, so I'm going to separate that out. Okay, so I'm to here. And then one more thing I can do is I can bring the 3 down in front using property 3. And then I've expanded it out as much as I can. All right, I'm going to stop the video. I just wanted to do a few more problems, trying to clarify, what I really want to see and try to help you kind of think through it correctly. All right, so let me stop.